Hello, welcome to your lesson on binomial distribution. Great topic, kind of tricky. Let's pay close attention. This is quite a big idea in the land of probability and beyond, so let's get into it. We're going to take some notes. You have been given a notes page. Please take notes right onto that. To begin, we're going to compare permutations and combinations. Permutations, to define it, are all the ways to order items or selected items when the order matters, and combinations are all the ways to order selected items when order does not matter. Let's look at what that means through this example. So we have three students. Let's call them Ina, Kirards, and Azila. Okay, in situation one, two of these three students are selected, with the first one selected getting a $100 prize and the second getting a $25 prize. So in this case, the order you select them in matters, right? Because if you select Azila first, she gets 100, but if you select Ina first, she gets 100. And so it matters if you're first or second. So let's take a look. Here the order matters. And here are all the possible permutations when the order matters. So here we go. AK, that means Ina first and Kirards. That's one order that you could select, two people. Okay, or you could have done KA backwards, right? Because since the order matters, even though those are the same two people, Ina and Kirards in both cases, the order matters because the first one selected gets a bigger prize. Another selection could be Ina and Azila, or again backwards, Azila and Ina. And finally, we could have Kirards and Azila, or Azila and Kirards. So there are 6 different ways, or 6 permutations in which we can select two people. And again, even though these are the same two people here and here and here, the order matters, so we count this twice. So 6 options. Now, situation 2. There are 2 selected, again, but this time each is given $25 only. So now the order you select them in doesn't matter. It doesn't matter if you're first selected or second, you still get 25. So order is no longer important. So here, order doesn't matter. Therefore, we are going to list all the combinations. So when order doesn't matter, they're called combinations. In this case, we can say we have all the same possibilities, right? AK or KA, and then AE, EA, KE, and EK. However, this time order is unimportant. So if you look at this first pair, which again were the same two people, we're going to cross one out because the order is not important. So we only count that as one option. When you repeat the elements like that, it's only one option. And likewise, we cross this one out, this one, because when we have the same two, it really is considered like the same thing. So only 3 combinations. Okay, so looking at that, there is a formula for permutations. It looks like this, and there's a formula for combinations also, which we'll look at in a moment. So permutations. Sometimes we see it written this way, and this is read n choose r, or here n choose r. And sometimes you'll see it written like this. It's 3 choose 2. And what that means is that 3 and a 2 could have gone here, so we could have had the 3 and a 2 here, or the 3 and a 2 here, or like this. I'd say this is probably the most common way you'll see. But anyway, 3 choose 2 means we have 3 things, or in this case we had 3 people, from which we have to select 2. And since we're using a p here, that's a permutation. And the formula is this, n factorial over n minus r factorial. And what that means is n factorial is that value, right, the number we're choosing from, 3 factorial. I'll tell you what that symbol means in a minute. And on the bottom, 3 minus 2 factorial, n minus r, so that minus that. Then you calculate that. 3 factorial, all that means in mathematics, this is actually a mathematical symbol, it just means 3 times 2 times 1. And on the bottom, 3 minus 2 is 1, so we have 1 factorial, so that's just a 1, because we're not multiplying and counting down because it's already 1. So 3 times 2 times 1, and that gives us 6 over 1, which is 6. And that makes sense. We already saw there are 6 different permutations, or 6 different ways you can choose 2 people. Now let's go to the combination formula. And there's that 6. The combination formula looks the same. We can say n choose r, or we can say n choose r like this with the c for combination. And here's the formula. Looks identical to this one, except now there's an r factorial in front. And by having that extra multiplier there in the denominator, we're going to decrease this number because we're basically going to take what we have and divide by an extra bit. So let's take a look. So again, n factorial, 3 people, and choose 2 of them, right? 3 choose 2, so 3. We're choosing 2 people, so that's the r value. And then again, n minus r, 3 minus 2. So 3 factorial, 3 times 2 times 1. On the bottom here, this 2 factorial is 2 times 1, and this 3 minus 2 is 1, right? So we can see that we have 6 divided by 2, which is, in this case, 3. And notice that matches what we had here. There was 3 combinations there, 3 ways to choose 2 people when the order doesn't matter, right? So the order is not important there. And notice that dividing by that extra 2 there is what reduced it from 6 to 3. So make sure you have those 2 formulas down, but I'm going to say actually in the work we do, it's the second formula that's essential. We're going to be using this one from now on. This was just to introduce you to both of these things, but know that we're going to look at combinations from now on. So write this formula down before moving on. Okay, so let's go on to the next thing here. We have combinations. So try a few. Here's 5, choose 0. So try to use that combination formula we just used and see if you can come up with an answer for that. Maybe in this one you paused for a moment, because if you use the formula, here's your n, here's your r, and here's your n minus r. But you end up with a 0 factorial, and maybe you're thinking that equals 0. But as you may not know or may know, a 0 factorial is actually 1. So on top we have 5 times 4 times 3 dot dot dot. That means just times 2 times 1, right? On the bottom, 0 factorial is 1. And then here's 5 minus 0, which is 5 factorial. So 5 times 4 times 3 times 2 times 3. I'm not writing it all out, because what happens now is you have these ones cancel. So the 5's cancel, 4's cancel, 3's cancel, and then the 2 and the 1, those would cancel also. And what are we left with? Well, we're left with, on top, when these cancel, those turn into 1. So we have 1 over 1, which is just 1. So that's the answer to that one. 5, choose 0. All right, try this next one. 5, choose 1. Okay, using the formula 5 factorial on the bottom, 1 factorial, and 5 minus 1 factorial. So again, 5 factorial, 5 times 4 times 3, dot dot dot, on. And on the bottom, 1 factorial, so 1, and then 5 minus 1 is 4 factorial, so 4 times 3 times, etc. Now what cancels here? Well, the 4's cancel, the 3's cancel, and then on, the 2, 1, all that would cancel, and you're left with just 5 over 1, which is 5. Try one more time using the formula. Try this one. 5, choose 2. And again, we're assuming this is combinations, not permutations. Okay, setting up the formula. 5 factorial over 2 factorial and 5 minus 2 factorial. So 5 factorial, again, 5 times 4 times 3, dot dot dot. And on the bottom, 2 factorial is 2 times 1, so I wrote it here. And 5 minus 2 is 3 factorial, so 3 times 2, etc., etc. Canceling, so 3, 2, 1, and all that cancels. So on top I have 20, on the bottom I have 2, so 20 divided by 2 is 10. Okay, well that's funny, that appeared now. It would have been useful to have that a minute ago, but anyway, there's the factorial, there's the combinations formula. Hope that you had some success, particularly by the third one, right? Because after 2 tries here, hopefully the third try was perfect. So now you know the formula. Okay, so another big idea coming at you now, and we're going to combine this with what we looked at in a second. So now we have something called Pascal's triangle. This is a very famous pattern in the world of math. Do you notice a pattern here? What's going on? Imagine looking from here to here and then down again, down again. How would you get the numbers in the next row, for example? Okay, let's take a look. So, by the way, this row is usually called row 0 on top. And then row 1, row 2, row 3, and now we're going to add row 4. If you spotted the pattern, you have noticed that to get one term here, for example, is 3, you take the 2 diagonally above it and you add them up. So 1 plus 2 makes a 3. Or here we had 1 plus 1 makes 2. And along the edge we always have 1s. So we're going to start with row 5, row 6. Okay, so row 4 we're going to start with a 1, and then this 1 plus 3 makes a 4. And then this 3 plus 3 makes a 6. And 3 plus 1 makes a 4. And then a 1 along the edge. So what about row 5? Okay, well 1 and then 5, because those make 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. And then 1 again. And finally row 6. So hopefully at this point you got the pattern going. So that's called Pascal's triangle. And now let's look at something interesting there. So remember we just solved that 5 choose 0 as a combination gave us 1. And we found out that 5 choose 1 gives us 5. And we found out that 5 choose 2 gives us 10. Now, do you notice something? Okay, well, looking at Pascal's triangle, notice that we have a 1 there. Well, everywhere is 1, but anyway, there's a 1. Here's that 5, and there I see a 5, and then I see 10 next, so there's a 10 right there. Okay, so interesting. When we do these combinations, they actually give us these values in Pascal's triangle. And this top number here can be considered our row number. So in row number 5, we can produce a 1, a 5, a 10, and if you kept going here, so 5 choose 3 would be a 10 also, and the next one would be 5 choose 4, and this would be 5 choose 5. Notice in that row we have 6 elements in it, but it's row 5, right? So each row has one more elements in it than the row number, because we begin with 0, and we can go all the way to 5 choose 5. Okay, that's a really important thing to notice there, and it's going to tie a bunch of things together in just a moment. So moving on, well, you can also do these on your calculator. So again, these are the ones we just looked at, 5 choose 0, and it was this whole row here, right? These can be done on your calculator. Let me show you how. In case you have the calculator app downloaded on your phone or your computer, or you have a calculator at home, I'll show you how you can do this now. So you can do it quicker than using the formula. So here's how it's done. So you have your calculator. I'm going to turn it on here, and you're going to press the math button. Math. In math, you have all these options on top. I want to go to probability, so I'm going to use the arrow to arrow over to probability. And now you can see here's permutations, and number 3 is combinations. So I'm going to choose number 3. It says answer here. The way to enter these is you have to put the number first and then number here, right? So I'm going to do 5 choose 1, for example. So I'm going to go arrow over there, type over that 5, and then go past that 1. So that's like saying 5 choose 1. That's the same as this. Enter, and we know 5 choose 1 should be, it should be the second one in row 5, because this is 5 choose 0 and this is 5 choose 1. So let's see if it gives us 5. Enter. There we have 5. All right, let's try another one in that. Let's try one in row 6. For example, row 6 would be 6 choose 1, 0, 1, 2, 3. Let's do 6 choose 3 and see if we get 20. So actually I can go again, math, probability, and number 3 for combinations, and I'm going to arrow over to there so I can go over that. 6 choose 3 again, because it's 0, 1, 2, 3. This is choose 3. Enter. It should give me 20. There's the 20. All right, so there's 20, and also it's in the triangle. So great, important patterns. I think, let's see, what's the next thing here? Yeah, all those, if you punch those in your calculator or you calculate them, there they are, 1, 5, 10, 10, 5, 1. And again, we have 1, 5, 10, 10, 5, 1. Yeah, take another look at that. Make sure you got that idea deep in your brain now. And next is going to be tying some of these things together. So I want you to end this part. This is video 1. There'll be a video 2 coming up in a minute with some more problems to try. To finish video 1, let's see if you can fill in all the rows. There's a blank triangle like this on your page. Fill them in with the combination lettering. For example, 5 choose 0 goes there, and then the next one, what's it going to be? So fill in the whole triangle with what should be the combination symbols all the way through. It's going to be a lot of a lot of C's in here with numbers, so see if you can fill it in. Okay, let's check. So that's it, right? We have 0 choose 0 because that's row 0, 1 choose 0 here, 1 choose 1, row 2, 2 choose 0, 2 choose 1, 2 choose 2, and then 3 choose 0, 3 choose 1, etc., etc. That will give you all the numbers in Pascal's triangle. And yep, next video will begin right in this spot. So don't quit yet. That was just the introduction, some big ideas and formulas and so on. And now we're going to see how we use those to move on with something called binomial distribution. So go to the next video now.